Hello, folks. This is Corey with Nuts and Zolts. Today is the first day of my thing a day challenge, where I try to design a unique object every single day. Not really touching upon old designs. It's a challenge. Sometimes I miss a few days, but this time I'm going to stick myself to a schedule and try to do it. Today, the first day, we're designing one of these thingies right here. What is this thingy? It's called a clamp or a clip or a retainer. I don't really know because the auto industry hasn't really decided what they're called. I like to call them toggle clamps, I guess, because if you look at them, see this little feature in the middle, that's the most important feature. What happens is a T key kind of pops through and then twists. And what this does is it keeps your floor mat attached to the floor of your car. And my partner has a car that has the mat has pulled through with the clamps staying put. I have another mat right here as an example. This is how the clips are used. That's the clip that came with the mat. You can see that it clips on to the other side with a white retainer ring. And then here's the one that we designed. So you see it's kind of similar in design. That is the top. So Prius, right? That's the top. And then the back, we decided to use a threaded design. See if I can get some light on the threads. You can't really see the threads. If I get closer, you're out of focus. But you get the idea. So, here's the design we came up with. It's two pieces. It threads on. So I'm going to go ahead and unthread it. And in the design, we made the male threads, right? And then on the inside are female threads. We made them an on shape. So I'm going to go ahead and show you. You can see right there that the shape is in the corner. And we'll go ahead and take a look at how this was made. This isn't going to be an instructional video. It's just going to be me showing what I did to make this particular part, which is somewhat instructional. One of the great things about parametric modelers is they are self-documenting. So by observing how I built this, you'll get a sense of how something else like this could be built. So I'm going to go ahead and switch over. Now my face is small. Oops. Go ahead and take a look at this object. Right now I'm in section view, so you can get a view of its insides. Allow me to hide some of these parts. So here are the two parts. You'll see that there's a threaded ring that goes around the cap. This is the top. That's the part that you would see in your car. This is the part that just holds the mat up. There's some cleats on the inside to give it a little extra traction. That's actually to keep the top from twisting when you are screwing this one on. That way you can keep this key oriented parallel to where the key enters, and then it flips over, the toggle goes vertical, retaining the clip. So let's go ahead and just take a look at the top part with the bottom part removed. Fairly simple. You pretty much saw all of this before. Critical dimensions were, of course, the size of the hole needed to be identical to what the original part had. Then these two holes right here retain little nubs on the underside of the key to kind of lock it into place a little more positively. This dimension from that surface to that surface, 6.55 millimeters, was a critical dimension to make sure that the there was positive lock. And then this circular portion, oopsie, the circular portion needed to be larger than the hole because the original part pulled through the mat, and therefore the hole that was left was bigger than the OEM made. So it was something that we needed to basically modify. Why we couldn't go with an OEM part. So let's go ahead and hide the top and take a look at the bottom. Fairly derivative of the top part. You can see that there's a thread there as well. We'll go over how the thread was made briefly. That will be an instructional part of this video. And then you'll see that there are some cutouts here. That's just for thumb positions and finger positions because you don't use a tool when you put this in. So we want to make it a little bit easy to use. This should work with any of the mats that use this kind of toggle key configuration. We looked online, and these are about 60 cents a kit from Alibaba. So if you wanted to get them, you could. If you wanted to wait a few weeks, if not a month. But the problem remains that the hole in your mat might have fallen through. So let's just go over the design. Here are the features of the design. You can see there are quite a number of them, and I didn't bother labeling them because why? This is a thing a day. I'm not going to be spending too much time on this in the future. So let's just rewind, and I'll show you kind of how I think parts through as I'm designing them. The first thing I like to do, I like to lay out my design, all of the major components in one sketch. This allows me to quickly make adjustments to the design. It's a way of organizing. Of course, this is kind of a muddy way of organizing because you can't neatly label this sketch to describe any one thing that you're doing in that sketch. But it does make it an easy way to organize things if your mind works that way. So after the sketch, I went ahead and extruded what I thought was the most critical component, which is this little retaining ring. It has critical dimensions in that it needs to be a certain thickness. The toggle area needs to be large enough, as defined by the sketch. And we needed to select the outside, which kind of represents where the toggle can freely move through, if you can see that. That one's easier to see. So then sketched again, this kind of represents where the top is going to be and the overall dimension of the positive and negative portions of the threading parts. So I'll go ahead and show you. Here we go. We have the internal screw and we've got the external thread. And this represents kind of a union of the two. Eventually, we're going to divide that into two parts, which will be done with a sweep. But this thick portion represents both. If we go back to the sketch, you'll see that there is a line right here that we use to guide where the teeth threads are formed. So let's go through this quickly. We don't need to be so slow. Sketch. What was this? Just extruding in the other direction. You can see that we're extruding. This is slightly larger diameter, 18.9 millimeters versus 18.4. So there's a thin difference between the two. That might not be a critical dimension, but we were just copying the original. This line represents the top of the external thread part, right? That represents the actual thread part of the second part. So right now we have both parts overlaid on top of each other. Extrude 6. Extrude 6. Where are you, Extrude 6? So this is where we made a surface. The surface is critical for the next step, which is critical for the threads. So we made this surface, which is basically just extruding a line from the original sketch, right? You can see that right there. We selected that to define a helix, right? If I get rid of these other two parts and the sketch, you'll see that that is a helix that's going down. That's the path that the threads are going to take. This is, if we're going to make this a lesson of anything, it's how you make threads in Onshape and other tools. Next is the sketch that represents the teeth. So when you're designing a thread to be used with like a standard screw, you have to be a little bit more diligent about how you make these dimensions, because you have the internal dimension of the screw. That's called the minor diameter of the screw, major diameter of the screw. Then for the nut, here's the major diameter for the nut and the minor diameter for the screw. You'll see of the nut. So here's the major diameter of the screw, minor diameter of the nut, minor dimension of the screw, major diameter of the nut. And that's because this is further out and further in. That's the difference in major and minor. Both of them should have a relatively similar pitch diameter, which is kind of the nominal diameter. And you'll see that this point right here represents that for our thread. And it is on the surface of the cylinder, the surface that we represented, that the sweep is going to follow. All right? So what is this sweep going to do? This sweep is going to cut through. So this sweep cut through the thread for the top portion. We haven't made the top for it yet. You'll see it also made a kind of a third part, but we go ahead and delete that. Kind of extraneous. Here we extrude the top because we wanted to cut that thread and then combine it with the top next. Just we didn't want to thread the top, so that's why we did that. Next is the sweep for the bottom portion. So no threads. Threads. Come on, let's go. Boom. Here we go. So now that we're done with that, we're done with the curve. We're also done with this sketch that represents the thread. Now we're just filleting. Probably filleted that. We filleted here to make it nice and smooth. More fillets, make things smooth and strong. More fillets to make things more smooth. Sketch 3. This right here, grommets typically have a kind of trough channel cut into them. So I made this sketch and then I revolved it around the center, kind of carve that space away. It gives the rim here the ability to apply pressure to the surface and then place for stuff to go. And then started making teeth. There's the teeth. We go down here, we extrude the teeth. We fillet the teeth. There was an erroneous face up here. So we just deleted that. Oop. Then a circular pattern. Add those teeth in extra places. And sketch 5. What is sketch 5? Sketch 5 was how we cut the finger holes for it. There we go. Extrude 1. Circular pattern. Deleting part, that's just this extraneous part here. Sketch 6 is just it's hard to bevel a screwed edge, so you can't just use the bevel tool. So I made another revolve, beveled the edge for me. And that was to improve the edge on the bottom part down here. specifically for 3D printing, you get something that's called elephant foot when you're smashing the first layer into the bed. So by putting a chamfer there, we get rid of that problem. That is the part. Part done and dusted. I hope you found that interesting. Again, it's just part number 1 of 31 for this month, and we will see you later. Thank you for watching.